Hello and welcome. My name is Patrick Stünkel and I'm going to present you a short introduction to our paper, GraphQL Federation, a model-based approach. This is joint works with Rutle from Bargen and my supervisors Adrian, Rutle and Yngve Lamo. So concretely, I will be talking about what is GraphQL, what is federation and what does it mean in the context of GraphQL, and how is this whole thing an instance of model-based software engineering? So starting out with GraphQL and some hard facts. It is a framework for developing web services as an alternative to SOAP and REST. It was developed internally by Facebook and then open sourced in 2015. And it could be considered to play in a similar league as Google's protocol buffers or Apache Avro, if you have worked with them. And the main idea it is schema first and it is domain oriented. What do I mean by this? So usually a web service interface is just a set of methods for retrieving data or invoking a method. But in this case, the web service interface should not be this collection of methods, but it should be the domain model. So how does it work? The idea is based that you define it as a schema, which is defined in this GraphQL schema definition language, which should intuitively look quite familiar if you've developed your own entity frameworks maybe before, or if you work with something. You basically define types which are attributes, and together they form a graph because they have references between each other. And then for every field, like the field customer in the type query, or these three fields in the type customer, you write a resolver function. So in this case, the type query is a kind of a special type in GraphQL. There are two special singleton types, query and mutation, which serve as an entry point. And these are implemented basically by some database request. And then for the attributes of the entity types, like customer, they're usually just a getter. And actually, because this case is so common, you actually don't have to write them. So this is how you define it on the server side. And how does it now look for the client side? So I'm just loading up this client here. So the client doesn't invoke a method, but he can declaratively specify what kind of data he's interested in by writing a query, which is shown on the left. So when invoking the query, we get a response from the server, which basically retrieves it as a JSON. And what do we write here in the query? This is based on what is present in the schema. For example, we have this special query type, which offers different entry methods. And then from there on, we can go into nested queries and retrieve nested data. And we can flexibly decide what kind of data. For example, if we remove the email, we will just get the name and the next one. Or we can add other fields. For example, we can get all the purchases and then navigate further down. For example, a purchase as in reference to the store, and from there on we can go further to the address, and then we can maybe ask for the street. And this will now retrieve us all the respective data. And this way it makes it really flexible so that the teams developing front-end and back-end can mostly work independently as soon as they have agreed on the common domain model, which is basically the unique selling proposition of GraphQL. But now thinking of this in the large, so especially following this current microservices trends, it usually ends up you have a lot of systems, and when all of them have their own GraphQL endpoints with their own schemas, it usually comes that you have informational overlaps. For example, in this example on the slide here, there's a system for invoices, a system for sales, and some HR system. And we can easily think that the customers are probably represented in both of them. And we even might think of employees that purchased products from our own company and then maybe get a discount. So we have the same data somehow scattered about these systems, and we often need a global, comprehensive view of all of them. And this is basically given by the idea of a federation, that is an endpoint or web service that collects all the data together into one. So, and because it's domain model oriented, we can basically look at the domain models. So, and here we can identify, for example, we have customers and clients, which basically represent the same entity. We have employees, which might be also be clients, and addresses is actually the same. So, and when conceptually all of this is just an example of multi-view modeling, because we have multiple models or views on the same underlying distributed systems, and where a model is represented by a schema and the respective resolvers. And this is just a general overview about the most typical approaches on how to integrate different views. There's a lot of excellent content in the literature dealing with this. So just to give you a short impression, and for our approach, we will go with cross-references, which also are known under different names like commonalities or correspondences, traceability, links are just some examples. So the idea is that we have multiple scattered schemas, and now we establish links over them. And we do this by creating our own DSL. So first we need a set of endpoints that we somehow want to integrate. And then what we do, we define relations between types. We have this relate statements, and we give an alias for these new types. For example, we integrate all the single inquiry types, because to get a comprehensive entry points for federated endpoints, and we have our customers, clients, and employees. They should also be considered the same entity, and we just name it partner. And we cannot just only relate types and align them, we can also do the same with fields. For example, here we align the fields that retrieve all customers, clients, and employees. Or here in our customer type, we just identify their names and their addresses. And important is that both the owner, which is given here, and the target type has to be related already, because in the end we want to merge them. So what we do here, for example, to merge payment details, we have to, here down below, we have to relate the payment details and bank details. And what we also can do is, because we just define a type relation so far, but this doesn't mean that we actually also identify data elements, because without this statement, we would just querying the federated endpoint would just get us a collection, a concatenation of all results. But by defining an identification, we can actually define keys when elements from different databases should be identified. For example, when customers and clients have the same ID, they should be considered same. Or when their name is actually the concatenation of first and last name in the HR database. And this allows us to consolidate data from different endpoints. And the result will be a consolidated schema where we have merged common types into one and collected all together. This will be the final result. And we have the pre-existing resolvers, so our federated endpoints, which we produce in the end, will just aggregate data from all the existing. So to get the big picture, first the user has to define this cross-references in a core spec using our DSL, referring to the existing schemas. Then our tool reads this, generates an own application, which will be a GraphQL endpoint. And this endpoint is just implemented by forwarding all the queries and consolidating the results from the existing endpoints we already have. Okay, trying this out shortly. Here we have our generated federated endpoint, and it just behaves like normal endpoints. The only difference is that it's now aggregating data from all the others. Summing it up, we have shown that MBSE concepts also appear outside of the Eclipse world and actually in open source frameworks, because industry has discovered that declarative and domain-focused approaches are worthwhile. Interestingly, multi-view modeling problems appear here as well, and we can just apply the existing theory, for example, model merging, in this field, and it turns out to be quite useful. We created this prototype, which already looks promising, and it can compete with an existing tool in the field, Apollo Federation, which has a similar goal, but is conceptually a little bit different. Much more details can, of course, be found in the paper, and yeah, there's a lot of features to be implemented and a long way to go, but it seems like an interesting first step. Yes, so I hope you have just now a little bit more clear picture of what is in the paper, and I hope you check it out and maybe have a look at our tool or just leave a comment below. We're always looking forward for your input.